Hello again, math friends. Welcome to this episode. Today we're going to look at rational expressions. And we're going to be simplifying those rational expressions. So first of all, let's talk about what a rational expression is. It's the ratio, which remember, ratio means fraction. So it's a fraction with polynomials. So there are polynomials in the numerator and or denominator. And that's what a rational expression is. Let's start by looking at this problem. We have a complex fraction. We need to simplify this. The easiest way to do that is to multiply the top and the bottom by the common denominator. So there's an understood 1 under each of those. So I have a denominator of 1, x, 1, and x. So the common denominator for all four of those fractions is x. So I'm going to multiply the top by x. If I do that on the top, I must do that on the bottom. Distributive property, x times 3 is 3x. Here the x's divide out and I get plus 2. Here 4 times x is 4x. And here the x's divide out and I get plus 5. So I took this complicated expression and simplified it down to something that was not quite as complex. Okay, once again we have something that looks complex, but I have one fraction here on the top, one fraction here on the bottom. The denominator is the same, so that is the common denominator. So I'm going to multiply the top by x minus 1. And I'm going to multiply the bottom by x minus 1. Whatever I do on the top, I must do on the bottom. So here the x minus 1's divide out. I'm left with x minus 5. And here the x minus 1's divide out, and I'm left with x minus 3. Those x's cannot divide out because that x is tied to that 5 with that minus sign. This x is tied to that 3 with that minus sign. So these are binomials. You can't break up pieces of binomials. So that ends up being the simplified version of that. Okay, now this time our common denominator is a little bit different. So we might also want to look at this in a slightly different way. I've got a fraction over a fraction, and really what that means is the one on the top divided by the one on the bottom. So this is another approach to working these problems. This is probably going to be a little bit easier and a little less complicated than multiplying the top and bottom by the common denominator. Whenever we're dividing fractions, we change to multiplication, and the second fraction we take the inverse of that fraction. It flips over. Change division to multiplication, flip the second fraction over. Now we're just multiplying. So I have x times x minus 2 on the top, and I have 3x times 2x plus 1 on the bottom. I can divide out one of these x's with the 1x down here. So on the top I get x minus 2. On the bottom I get 3 times 2x plus 1. So I've taken this very complex fraction, broken it down to something that is much more manageable. Okay. Here we are multiplying these two together. So whenever you're multiplying, we can go ahead and multiply what's on the top, and we can go ahead and multiply what is on the bottom. And since we are multiplying these, this binomial divides out with the same binomial in the denominator, and so we're left with 2x over x plus 3. Okay? Now we have a little bit more complicated issue. This time we've got to do some factoring, and so I'm going to need to factor this trinomial. I know that trinomials factor into two binomials if they're factorable. And so my factors of 15 are 5 and 3. Because I know I need a 2. I can get a 2 with the 5 and the 3. I need negative 2. The 5 needs to be negative. The 3 needs to be positive. X times x is x squared. Outsides I get x times 3 is 3x. Insides negative 5 times x is negative 5x. That gives me the negative 2x. And negative 5 times positive 3 is negative 15. On the bottom, factors of 6 are 1 and 6, 2 and 3. I know I need a 1. I can't get a 1 with 1 and 6. So I'm going to use 2 and 3. I need a negative 1, so I'm going to make the 3 negative, the 2 positive. So when I multiply this back out, I get x squared minus 3x plus 2x is a negative 1x, and 2 times negative 3 is negative 6. Then I need to factor x squared plus x minus 2. I've got x and x. Factors of 2 are 2 and 1. I need a positive 2, so I'm going to make the 2 positive, the 1 negative. When I multiply this back out, x times x is x squared, negative 1x, positive 2x gives me positive 1x, and plus 2 times negative 1 is a negative 2. And finally, on the bottom, factors of 3 are just 3 and 1. I need a positive 2, so I'm going to make the 3 positive and the 1 negative, so that when I multiply this back out, x squared, 3x, and negative x gives me the positive 2x, and negative 1 times positive 3 is my negative 3. Now, I can just multiply everything together on the top. And multiply everything together on the bottom. We do not need a common denominator when we are multiplying and dividing rational expressions. Now let's see if anything will divide out. The x plus 2's divide out. The x plus 3's divide out. The x minus 1's divide out. And we're left with x minus 5 over x minus 3. So multiplying those together, factoring, multiplying everything together on the top and bottom, divide out factors that are in common, and we're left with x minus 5 over x minus 3. Alright, let's remember that this means 2x squared minus 5x plus 2 over x squared plus 3x minus 10 divided by 2x squared plus 9x minus 5 over x squared plus 7x plus 10. So I'm going to go ahead and start doing some factoring just to save some time. Factors of 2x squared would be 2x and x. I need a negative 5. If I put a 2 here and a 1 here, that gives me 4 and 1. If I make both negative, I can get negative 5. Negative 4, negative 1's negative 5, and negative 1 times negative 2 gives me the positive 2. On the bottom, factors of 10 would be 5 and 2. We need a positive 3, so I'm going to make the 5 positive, the 2 negative. And so x times x is x squared, negative 2x, and positive 5x gives me the positive 3x. Positive 5 times negative 2 is negative 10. Then I'm going to change to multiplication, and this fraction flips over, so I'm going to factor this on the top. Factors of 10 are 5 and 2 again, but this time we need a positive 7, so if I make both of those positive, I get x squared, 2x, and 5x is 7x. 5 times 2 is positive 10. On the bottom, I've got 2x and x, and we need a 9 with our 5. So if I have 10 and 1, I can get 9. If I make the 10 positive, the 1 negative, 2x times x is 2x squared. 2x times 5 is 10x. Negative 1 times x is negative 1x. So 10 and negative 1 is positive 9. And negative 1 times positive 5 is negative 5. Instead of writing all of this over into one fraction, I'm just going to go ahead and start doing some simplifying. And we're left with x plus 2 over x plus 5. We had factors that were being multiplied. Everything's being multiplied, so we can divide out those binomials that are in common and left with this. Alright, here we've got several things in play. So first of all, I've got 3x squared y to the 4th over, this is the difference of two squares, x plus 4, x minus 4. I need to change this to multiplication, flip this fraction over, so the 4x cubed and this should be cubed, 4x cubed y cubed, and then this trinomial, let's go ahead and factor it. And remember, the fraction flipped over because we changed from division to multiplication. Factors of 4 are 2 and 2, but that won't give me 3. If I use a 4 and a 1, I can get a 3. Make the 4 positive, the 1 negative. X times x is x squared. Negative x, positive 4x gives me the positive 3x. And positive 4 times negative 1 gives me the negative 4. And then on the top, we can factor out, let's see, we can factor out a 6 from both of these. We can factor out an x squared from here and here. And we can factor out, and I'm sorry, that should be multiplying, factor out a y cubed. And we are left with just an x plus, and we factored out 6. 6 will go into 18 3 times, and that's it. And then on the bottom, the difference of two squares again. You need to make sure that you can recognize the difference of two squares. You will see them over and over and over again. If you need help, go check out my video on the difference of two squares. Alright, now I'm going to start simplifying a few things. I see an x plus 4 divides out. X plus 3 divides out. I can divide out 2 of these x's and 2 of those, left with 1. The y cubes divide out. This x to the first can divide out with one of these x's. And so 2 will go into 4 twice, and 2 will go into 6 3 times. So on the top, I get 3, and 3 is 9. X, y to the 4th. and the x minus 1. Okay, so I had 3 and x minus 1 and 3 left. On the bottom, I've got a 2. Everything else there divided out. I have an x minus 4 and an x minus 3. So we're left with 9xy to the 4th times x minus 1, and on the denominator 2 times x minus 4 times x minus 3. So that ends up being our answer. All right, hope that was helpful. Hope you learned something. We appreciate you watching, and stay tuned. We'll see you on the next episode. Bye now.
If you liked this video, please click on the thumbs up. If you want to see more videos like this, please click on the subscribe button. And if you want to be notified when new videos are posted, please click the bell.